Good morning, Physics 20. I hope you guys are all doing well today on this lovely, chilly March Monday. So, our mission today, ladies and gentlemen, is we're going to be looking at two-dimensional forces. The beauty of this, ladies and gentlemen, is this is going to be exactly the same thing that we did in kinematics, except we're just going to be looking at different vectors. So instead of looking at displacement on 2D, we're now going to be looking at forces applied at 2D. So that's going to be when you're going to be pushing an object or pulling an object with two different forces. So have you ever had to move something heavy and by pushing at it? And if you have two people pushing at the same object, you got one person pushing this way, one person pushing this way, well, the net is going to be forwards like that. So we are going to be having x and y vectors that are going to be canceling each other out. So we'll take another field trip a little bit later to see what that would look like. So if you want to pause this video and then go on to the field trip video, you're welcome to do that before we come back to the calculations. All right. So let us select our pen tool here. So with our 2D dimension, let's try this again. With our 2D vectors, think right back to kinematics. So exact same idea. We are going to be having 2D vectors, and they're going to have an x component and a y component. So we were looking at displacement and velocity here. But remember, ladies and gentlemen, force is a vector. So because force is a vector, we are able to work with them the exact same manner that we do any other vector. So you can have a vector with a force pushing on it at 70 newtons east and another force pulling on it with 30 newtons south. So if we're going to draw that, well, 70 newtons east would look like this. Now remember, when you draw your vectors, I want to see arrows on the vector so I can actually see that direction. And I also want to see approximate size, so 70 newtons should be a bit bigger than your 30 newtons. More importantly than that, though, I need to see your vectors tip to tail. If your vectors are not drawn tip to tail, you're not going to actually get a proper resultant velocity. Okay, or velocity, resultant vector. Okay, it's a little bright in here. Maybe if I turn the side lamp off. Is that a bit better? Can you see better? Okay, at least a little bit. Okay, so tip to tail. Okay, so then you have your 30 newtons. Well, guess what now, ladies and gentlemen? We have our resultant. And guess what? We can find theta. This all looking pretty familiar? Hope so. Okay. Now keep in mind with this example that we just drew here, that is having two vectors that are on the perpendicular to each other. Now, maybe if I turn this computer screen off. It's a little better. Okay. The thing about having vectors on the 2D, some are going to be perpendicular to each other and some are not going to be perpendicular to each other. When they're not perpendicular, can we simply draw them tip to tail and Bob's your uncle use Pythagorean theorem and trig? Nope. Next year, when you guys have finished taking Math 30 and grade 11 math, you will have learned sine and cosine law. Those you can use with vectors drawn tip to tail that aren't perpendicular to each other. We'll talk about that next year in Physics 30. But we can't do that now because you guys haven't learned sine and cosine law in math, and we're not going to jump the gun with the math curriculum. So when you have vectors that are not perpendicular to each other, that means, remember, you have to break them into their x and y components first using trig. Then we can add the x and y components together. Okay, so watch out for that. That's probably the most common mistake I see with 2D vectors, so be aware of that. Okay, so ladies and gentlemen, I want you guys to put a really big star right here. If we were in class, I would write on test, but we're not in class, which is really sad. I do miss you guys. Okay, so we're going to write on assignment instead, because I will give you assignment questions on this. Okay, never abbreviate assignment to its first 3 letters. Doesn't work so well. Okay, so ladies and gentlemen, if your vectors are perpendicular to each other, so that would mean you are going to have vectors like north, south, east, and west. You are going to have 2 vectors that are on those axes. If you have these, the vectors are going to be, if you have north and east, and if you have south and west, they're going to be completely perpendicular. You follow those steps then. So if that's the case, you're going to draw your vectors tip to tail, and you're going to make yourself a right angle triangle. Very important, tip to tail on the vectors, draw arrows on your vectors. And then you're going to use Pythagorean theorem, just like we did in kinematics, in order to solve for your hypotenuse. In this case, your hypotenuse is going to be your resultant force or your net force. Okay. Then you're going to use trig, and you want to find the angle, remembering that that angle is going to be from where you started, so at that starting point. Now, just like we did with our displacement, if the forces are going to be not perpendicular, that's the key. If they are not perpendicular, you are going to have at least one angle or one vector is going to have an angle like 25 newtons going at 45 degrees north of east, and then another one going south. That is not a perpendicular vector. So that is how you're going to watch for it. Okay, so we're going to write down, watch for angles in initial vectors. Okay, they will be, if there's an angle in your initial vector, you are going to have not perpendicular vectors. Okay, so then that's the case. You need to use these 4 steps here. So these are the exact same steps that we did earlier, okay, back in class. So step 1, you're going to have grid lines on each vector, and you're going to find the x and y component of these using trig. Okay, SOHCAHTOA. You do not need to memorize SOHCAHTOA. You already have that on your data sheet. Okay, and you are going to find your x total and your y total. I'm going to put a little star here. And I'm going to tell you here to watch, that's an H, your positives and negatives. That's very, very important there. It's another very common mistake I see is forgetting to put a negative on those negative directions or forgetting to put a positive on those positive directions and getting a wonky resultant as a result. Okay, redraw your new right angle triangle. Once again, tip to tail, with your x total and your y total, watching the directions. If you have a negative x total, that means it's going to be going in the negative direction, which we generally use as west. And if you have a negative y vector, y total, it's going to be going south, unless you've designated north as negative or south is positive. Okay, you're going to use Pythagorean theorem, and then to solve for your resultant, which is going to be the net force. Then you're going to use trig to solve for your new angle. Okay, and then direction. Okay, so we've got 2 practice problems we're going to do. One with perpendicular vectors and one with non-perpendicular vectors. Okay, so we're going to scroll along. Okay, so for this question, select pen. One person pushes on an object with a force of 800 newtons to the west, and another pulls on the object with a force of 550 newtons to the south. What is the acceleration of the object if it has a mass of 62 kilograms? Oh, this is a fun question. Okay, so the first thing we're going to need to do is we're going to have to find our F net. When asked to find acceleration, ladies and gentlemen, remember from your data sheet that acceleration is equal to F net over the mass. So we need to find our F net first. But look carefully at our vectors. We've got one vector that is going to the west and one that is going to the south. So that means they're perpendicular. When they're perpendicular, what do? Draw them, tip to tail, and use trig to solve, and Pythagorean theorem to solve. Ladies and gentlemen, because they're perpendicular, that's what we do. If they're not perpendicular, can we do that? No. Okay. Because they're perpendicular vectors, I am going to draw my 800 newtons going to the west. I am going to draw my vectors tip to tail with 550 newtons going to the south. This is going to be my resultant. My theta is going to be here. Okay. So, ladies and gentlemen, I need to find my F net, which is going to be here. My F net is my hypotenuse. So I'm going to use Pythagorean theorem to solve for this. Once again, I assume that by the time you get to Physics 20 that you can rearrange Pythagorean theorem without showing me how you did it. You still have to write this out. You still have to write out your equation even if you've prearranged it, okay? Pre-rearranged it. So your F net is going to equal your lovely value of 800 newtons squared plus 550 newtons. Square that, square root the lot. And once you have carefully put this value into your calculator, you are going to wind up with a magnitude of your F net with 970.824 ... newtons. Okay, so ladies and gentlemen, because we are asked to find acceleration, I'm not going to round here at this point. I'm just going to leave that as a full number. Make sure you have that available in your calculator so you can use that in our next step. Okay. Now, I'm going to find my theta. The theta of my force is going to be the same theta as my acceleration. Okay. So you can simply find theta with your forces. Now, in order to find theta, really, I could use sine, tangent, or cosine. It doesn't really matter at this point, except I'm going to use tan. Why am I going to use tangent, ladies and gentlemen? Why in class have I told you we use tangent in such scenarios? Because there's less math that has been done if we use tangent, less previous math. If I use sine or cosine, I'm using the hypotenuse. The hypotenuse has already had math done on it by us. Could have made a mistake, could have made a calculator error. So if you use tangent at this point, there's the least amount of math done on it that the value is given to you. So that means you're less likely to make a mistake. So tangent is opposite of our adjacent, and I'm trying to find theta. So my tan -1 is what I use to find my angle. And so that is then going to be my opposite is the 550. And my adjacent is 800. Make sure your calculator's in degrees, ladies and gentlemen, because if it's not, you're going to have a rad time. Get it? Get it? Rad, radians. Please be laughing at my jokes, guys. I don't have anyone to laugh at my jokes. Or at least glower at me when I make bad jokes. No? Okay. So your angle, ladies and gentlemen, is going to be here 34.508 degrees. Once again, I'm not going to round yet. I'm going to wait till I get my final answer, which is going to be acceleration. So because my acceleration is F net over my mass, well, we've been given the mass of the object as 62 kilograms. So I'm going to take my F net, which is going to be 970.824, leaving every single one of those digits in your calculator. And I'm going to divide that by the mass of 62 kilograms, which is going to give me my lovely acceleration of 15.915 ... meters per second squared. Okay, so I'm going to scroll down. And now we need to put everything together with our direction and with our magnitude and all and sig digs, all that good stuff. So my acceleration, well, let's go back and look at the question. So I've got 3 sig digs, so that means I want to have my rounding to 15.9 newtons. What would I be deducting half a point for myself right now for? Wrong units. Good job. There we go. Okay, the correct units are meters per second squared. And my theta, ladies and gentlemen, from previous was my 34.508. So once again, 3 sig digs. So 34.5 degrees. Now I'm going to come back up to my triangle and I'm going to think a bit about my reference point for my theta. So when you look at your angle, right over here, how we have theta from our starting point here. Well, we always start on the vector that's on one of the axes. In this case, the vector is that we were from where we started from is on the west axis. We start on that west axis and then we're moving south. So that means that our angle is going to be south of west. So south of the west line. Okay, so, oops, that's not what I wanted to do. So we're going to scroll down. And I'm going to give my angle a reference of 34.5 degrees south of west. Now remember, ladies and gentlemen, that there are 2 correct angles and 2 correct ways to draw your triangle. So I drew my triangle like this. The other correct way to do this, because there's 2 ways to correctly draw your triangle tip to tail. I'll actually draw this nicely here. And there we go. It's really hard to draw vertical lines on this thing. Would be south and then east. So now let's erase this random line here. Okay. We're going to assume this is a right triangle. Okay. So you could draw your value this way. Your F net, the magnitude is going to be exactly the same, ladies and gentlemen. The only thing that's going to be different is your theta. Now, if you take your calculators, okay, and you take your, yes, calculator, I know you have low batteries. So your 90 degrees minus your 34.5, you're going to get your 55.5. And if you go your tan -1 of, and this would be your theta here. Oh, come on. There you go. If that's your theta there, then your opposite would be this guy over this guy, and you would get theta as being about 55.5 degrees. Now your reference point is now going to be different. It is going to be west of south. Okay, so that's the other acceptable angle for this question. So keep in mind there are always 2 correct ways to draw your triangles, and there are 2 correct answers for your angle, and I will accept either as correct when I'm marking. So it's just a reason why it becomes even more important to make sure you're showing your work properly, right? Yeah, show your work. Okay, so ladies and gentlemen, let's make this a wee bit more tricky. Okay, we are going to do the same thing that we did with the 2D vectors that are going to be not perpendicular to each other. We're going to break these guys into their x and y components, and then we're going to find the total on the F net on the x and total F net on the y, and then we are going to make our new triangle. All right, so I need my pen. 2 forces are applied to an object. So 10.1 newtons at 36 degrees north of east and 4 newtons directly south. What is the net force acting on the object? Okay. Read the question very carefully here, ladies and gentlemen. Do you guys see this angle right here? We have a force on an angle. That means that these are going to be perpendicular, not perpendicular to each other. They're not perpendicular. Do not draw these vectors tip to tail and use Pythagorean theorem. It's not going to work like that. You are not going to get a right triangle. You are not going to be able to solve this correctly that way. You must break these into x and y components. Okay, so I'm going to start with the easy one. I'm going to start with my vector 1, which I'm going to decide is going to be this guy. So here we're going for Newton south. Now, because I have north and I have south, so when you look at this, we've got north of east, I'm going to make south negative and I'm going to make north positive. So my force on the x for force number 1 is going to be 0 newtons. There's nothing on the x for this vector. Going directly south is all y, all y. So that would mean my force on the y for force number 1 is going to be 4 newtons. However, think very carefully here. I'm going to make sure we switch colors here so that way it's easier for you guys to see this. Okay, -4. Okay, watch those negatives. Okay, now I'm going to look at my next vector here. So my next vector is going 36 degrees north of east. So my vector 2, I'm going to make it nice and big so it's easy for me to draw on. I've got 10.1 newtons here. It's going north of east. Well, I need to break this guy into x and y components. This here is going to be my F on the y for force number 2. And this guy here is going to be force on the x for number 2. So now I'm going to need to use my trig. So I'm going to need my theta, which is 36 degrees north of east. Okay, so north of that east line. Okay, so I'm going to start with x because I can. Now I'm going to look at this and I want to use cosine. Why do I want to use cosine? Adjacent of a hypotenuse. So my cosine of 36 is going to equal my x, my value of my force on the x, over my hypotenuse, which is 10.1. Now I'm going to rearrange this by multiplying by 10.1. So on those are going to cancel. So my force on the x for object 2 is going to be 10.1 times cosine of 36. Once you put that in your calculator, making sure it's in degrees, you're going to wind up with 8.17107 ... Now, this guy, ladies and gentlemen, I'm going to switch colors here again so we can see this direction. I'm going to think about this. My value is going towards the east. We generally designate east as being positive. Okay, it's also our only x vector, so we can leave it as positive if we want, even if it was going west. Okay, so now I'm going to switch back to red. Oh, come on, you. There you go. And now I'm going to find my force on the y for my vector 2. Now for this one, I'm going to use sine. Now the reason I'm going to use sine is my force on the y is opposite of that 36 degrees. So my sine of 36 degrees, wow, that's a really pale red. You can hardly see that. There. Sine of 36 degrees is going to equal, that's better, my y, that's supposed to be a y, over 10.1. Okay, so multiply both sides by 10.1. And my force on the y for my vector 2, I'm going to scroll up so I don't write on my face, okay, is going to be 10.1 times sine 36, which in your calculator is going to equal 5.93663. And we're going to switch colors again here so that way we can look at our direction here. Now it's very important for the y because we have both north and south vectors. So this one's going north and I chose to make south on my previous vector negative. So I am going to choose to make this guy positive. This guy over here, oh, come on, this guy here and this guy here are going in opposite directions. They have to have opposite signs. Otherwise, you're going to get the question wrong. Okay. So now I have my vectors all broken down into their x and y components, and now I'm going to find my totals. So my force x total, well, I only have one. I've only got this guy. So the other one is 0. Okay, so my fx total is going to be positive 8.17107 ... newtons. My Fy total is a different story. I have positive 5.93663 newtons plus my negative 4. Okay, this is where it becomes very important that you watch those negatives, ladies and gentlemen. You drop that negative, we wind up with about 9.9 newtons instead of our 1.9 newtons. So watch out for that. Okay, so as I'd mentioned, we have 1.93663 newtons, and it is going to be a positive number, so that means it's going to be going north. Okay, I scroll down. And now that I have my x and y totals, I can make my vectors on the x and y with this guy. I can draw my new triangle. So my x total is going to be 8 this way. So 8.1707 newtons going towards the east because it's positive. And now my next vector, ladies and gentlemen, is going north, my 1.93. I am actually going to write this a little bit neater here. I'm going to write this underneath this arrow instead of on top. Okay, so 8.17107. And then my north vector is going this way, which is 1.93663. That positive tells us it's north, and this positive tells us that we're going east. Remember, this is only one of 2 correct ways to draw your triangle. Okay, you can draw your triangle like this, or you can draw it the other way. And for no particular reason, I've chosen to draw it like this. Okay, there's my theta. So I'm going to use Pythagorean theorem to find my F net, the magnitude. And it's just going to be the square root of a squared plus b squared. And my F net is going to equal my 8.17107 using all digits from your calculator. Do not use these rounded numbers. Use all digits, ladies and gentlemen. Plus 1.93663. Square that. Square root the lot. And we're going to wind up with magnitude of our F net being our 8.397 ... newtons. Okay, Let's find theta. Once again, I'm going to use tangent. The least amount of math has now been done on my opposite and adjacent, so I'm going to use tan. So tan -1, well, find your angle, and opposite over adjacent is going to be 1.936663, and then 8.17107. And you're going to get your theta. Okay. Calculator. As I did this one differently than I did on my notes, so which is fine. So second tam, and then your 1.9366, and you're going to divide that by your opposite. Okay. And you're going to get a theta of 13.333 degrees. So remember, there's going to be two different correct angles with your F net, and we'll write down both of them here. So your F net is going to equal, I'm going to look back at the question, I've got 2 sig digs. That 4.0 newtons is 2 sig digs. So that means I'm going to have 8.4 newtons. I'm going to scroll up a bit so I'm not writing on my face. Okay, comma, and then 13 degrees, and according to this triangle, it is going to be north of east. So north of that east line. The other correct answer you can have is going to be 8.4 newtons, but when you take your calculator and you go 90 minus the 13.333, you're going to wind up with 76.66666. So that means we're going to have an angle that's going to be acceptable of 77. But remember, the reference would be different, so it would be east of north. There you go. Instead of north of east. So those are your two correct answers, ladies and gentlemen. Okay. All right. So ladies and gentlemen, if you guys have any questions, fire me an email and we can go from there. You will find the questions for the assignment for this one in your Dynamics Chapter 2 assignment. So that's where you'll find these guys, as we're now in Chapter 2 of Dynamics. And we will see you guys later. No fires, injuries, or explosions. And this thing will turn off again. All right. See you later.